The addresses we used in the previous lesson is part of Class C. There are three types of classes for IP addresses: Class A, Class B, and the Class C. Their differences are the number of hosts that it is possible to have for its network. Let's take an example. The first 3 bytes are the network part, and the last is the hosts part. So we can use the last octet so that our hosts can have a unique IP address. Computers on the same network can therefore very well have as IP 2, 3, and so on. As you can see, the network part is the same. On the other hand, a computer which carries the address IP 192.168.2.1 will not be in the same network since its network part. Suppose a computer wants to send a packet to another network. What will happen? To find out, it's very simple. If you are using Windows, just open the command prompt by typing cmd from the menu Start, and use the ipconfig to display the IP information of the PC. In the example, we see that my PC is in the network 192.168.1. If it wants to send something to another network, then it will use its default gateway. Here it is the address 192.168.1.254, which corresponds to my router. Let us return to the details of different classes. If you are using a network of Class A, then you could have lots of hosts in every network you create. If you are using a Class B, you can create more networks, but fewer hosts per network. And with the Class C, you will be able to build lots of networks, but with only a few hosts in each network. Just before, I told you that the address 192.168.1.1 was part of a Class C. But how to know? Well, in an address of Class A, the first bit must always be 0. In Class B, the first 2 bits must always be 10. And in Class C, the first 3 bits should always be 110. So if you calculate this from binary to decimal, it means that the address range of the Class A starts with 0000, in Class B it starts with 128.000, and in Class C it starts with 192.000. And so the exact range for the Class A goes up to 126.255.255.255, 191.255.255.255 for Class B, and 223.255.255.255 for Class C. If we look closely at the different address ranges of the IP classes, we see that the subnet is missing the 127.000. It is not in Class A. If on your PC you ping this address, you logically get an answer. This network is used as a loopback address. This is a loopback address used to check if the equipment's TCP IP stack is functioning correctly. To return to the IP ranges, we notice that Class C stops at 223.255.255.255. Well, it's because in reality, there is a Class D. Class D IP addresses are not used to assign them to computers. They are used for multicast. They range from 224.000 to 239.255.255.255. Now we will see the difference between private and public IP addresses. Public IP addresses are used on the Internet, and private IP addresses are used on your local network and cannot be used on the Internet because they are not routable. The private IP address ranges are 10.0.0.0 to 10.255.255.255 for Class A, 172.1.6.0.0 to 172.3.1.255.255 for the Class B, and from 192.168.0.0 to 192.168.255 192.168.1.255.255 for Class C. The IP address 192.168.1.1, which we use as an example from the beginning of the lesson, falls into Class C, and it is a private IP address. It is not routable on the Internet. There is one more thing to see about IP addresses. In the network, there are two IP addresses which we cannot use. There is the network address and the broadcast address. The network address cannot be used on a computer as an IP address because it is used to define the network. And the broadcast address cannot be assigned to a computer either, because a broadcast is an IP packet that will be received by all devices on your network. We will see now how to recognize these two IP addresses that we cannot use. We will take our Class C IP address as an example. We have to look at the last octet which is used for the hosts. If we set all the bits to 0 in our host part, we have this network address. 192.168.1.0 is the network address, so it is impossible to assign it for a PC. And if we set all the bits to 1, it gives us the broadcast address. 192.168.1.255 is also not available for a PC. To sum up, setting all host bits to 0 gives you the network address, and changing all of the host's bits to 1 gives you the broadcast address. And these two IP addresses are not usable for computers. Before starting routing, it is important to understand IP addressing. We will start by seeing the basics of binary calculus. In the binary system, we only work with zeros and ones. 0 translates to off, and 1 to on. The bit on the far left is called the most significant bit because it has the highest value, and the bit on the far right is called the least significant because it has the lowest value. We will see how to convert decimal numbers into binary. For example, if we want to convert the decimal digit 0, in binary this means that we leave all the bits on off. So at 0, now take the number 192. From the left, we will see the bits corresponding to the number. 128 is smaller than 192. We will therefore take it and put a 1. So we subtract 128 from 192, and we still have to find 64. This is the number just after. We also pass it to 1. The conversion of the number 192 into binary is therefore 2, 1, 1, followed by 6, 0. 128 plus 64 is indeed equal to 192. Let us now take the number 168 as an example. Always starting from the left, we tag bit 128. We therefore have 40 left. Since 64 is greater than 40, we don't take it. On the other hand, we will take the next bit, the 32. We just have set the number bit 8 to 1, and we have our conversion. 128 plus 32 plus 8 is equal to 168. If we want to convert the number 1 into binary, nothing could be simpler because the 1 match with the rightmost bit. An IP address that we find very regularly in the network is 192.168.0.1. Well, now we can convert it very easily into binary. One more for the road. The number 255. Here we take all the bits, which gives us 255. The number 255 is the largest number we can have with 8 bits. As you can see, every time we add a bit, the decimal value doubles. These are called powers of 2. We will now talk about IP addresses. An IP address is a numeric value that is configured on each device on a network. For example, a computer, routers, firewalls, and switches. It allows each device to be identified with a unique number. Devices on the same IP subnet can communicate without using a router. The IP address is made up of 32 bits, divided into 4 blocks of 8 bits, which gives 32 bits in total. We saw that by borrowing a bit, it allowed us to double the decimal value. This is the powers of 2 rule. We will now see a method which makes it possible to calculate subnets without necessarily going through the binary. This method is based on a number obtained by adding the 8 bits, which gives us 255. But as we must also count the 0, then our base figure will be 256. It is this figure that will allow us to easily calculate any subnet. As an example, we will use the 192.168.1.0 network with a mask in 255.255.255.0 that we want to divide in 2. So we take the block of 256 and simply divide it into 2. We now have 2 subnets for our Class C IP address. So all that is fine, but now we would like to know the network address, the broadcast address, the new subnet mask, and the IP addresses that can be used. And all this for the 2 subnets. For the network address, we will rely on our 2 blocks of 128. We start with the first IP. The 192.168.1.0 will be our network address for our first subnet, and the 128 for our second subnet. For the broadcast address, we know it is the last address in a subnet. For the first subnetwork, it will therefore be the 192.168.1.127 and 255 for the second subnet. Then, to know the subnet mask, we will subtract 256, which is the basis of our method, by 128, which gives a mask of 255.255.255.0. 0. And finally, we can deduce the usable IP addresses. The first IP address that can be assigned to a host is the one after the network address. And the last IP is simply the penultimate, i.e. just before the broadcast address. It is still faster than decimal, no? So now are you more binary or decimal?